자, 우리 시작해보자. 이번 주 숙제 어려웠어? 잠시만요. 오케이. 이번 주에 equations를 배웠지? equations. 자, 해보자. 여기서 어느 게 제일 어려웠어? 이 부분에서? 다 쉬웠어?
그 extraneous solutions.
아, extraneous solutions?
네.
오케이. 그럼 그거 나도 사실 지금까지도 좀 헷갈리긴 했어. rational equation 처음부터 해보자. 나중에 거기까지 갈 거니까. rational equations. Let's try this question first. Equals 1 over 10. 10 over 2q plus 8 equals 1 over 10. Who was able to solve this? 예지부터 해볼래? 이거 뭐 나오는지?
Is Q46?
Q equals 46. Okay, I think so. Let's move on. Let's do another random problem. Let's try negative 2 over x plus 2 equals x plus 3 over x plus 2. 이건 민혁이가 해보자. What does x equal?
이거
problem. Yeah.
x equal root 5 나왔는데.
X equals root 5. Okay.
네.
If you guys got different answers, tell me by the way. I'm just gonna move on. Or if you're confused on how the answer is the answer, then you can stop me. And yeah. But other than that, let's move on to another question. X squared plus 20 over x times x minus 2 equals 14 minus x over x minus 2. 이건 하늘을 가볼래? 이건 뭔지? 아닌가? 그럼 하늘이 빼고 시우가 해볼래?
I got 2 and 5.
2 and 5. Okay. So what I really didn't say is I was hoping one of you guys would catch it, but there are also extraneous solutions in this part of the question. So 2 is not a solution because if we plug in 2, let's say we plug in 2, right? It's 2 squared plus 20 over 2 times 2 minus 2 equals 14 minus 2 over 2 minus 2, right? And 2 minus 2 is equal to 0. And we can't divide by 0. So just 5 would be correct. But yeah, good job. I'm going to move on straight to inverses of functions. Since I think this section was okay for everyone. Inverses of functions. Let's try the second question. What is the inverse of f of x equals 5x plus 2 and x minus 3? I'm going to try this problem. I'm going to explain it since some people might have had a hard time. So f of x is the same thing as y, right? Or it's not the same thing, but it's very similar. So we can rewrite the equation as y equals f of x plus 2 over x minus 3. And from here, we said that inverse is inside out of the function, right? It's the total opposite. And what would be the total opposite of y equals something? Well, x equals something, right? So if we just switch every x we see with y and switch every y we see with x, then we can rewrite the question as y equals is going to be x equals 5x. It's going to change to 5y plus 2 over y minus 3, right? And from here, we want it back to where it's an equation. So we want to rewrite this as y equals something. So isolate y. So to isolate y, we need to get rid of the denominator. I'm going to multiply y minus 3 on both sides, leaving that. And I'll just multiply that out. So xy, I multiplied that out, leaving xy minus 3x is 5y equals 5y plus 2. And we want all the y's on one side since we're isolating the y's. So let's move all the y's on one side. Let's move the 5y and take out the 3x to the other side, right? And to isolate y, now we can factor y out from this. So if I factor y, it's y and x minus 5 equals 3x plus 2. And once again, we can divide by x minus 5. If we do that, then we're left with 3x plus 2 over x minus 5, since we divided by x minus 5. So all we did was rewrite this into a y equals something form. But this is going to be the inverse of this f of x. So to answer the question, what is the inverse of f of x? You might have written it like that, or you might have written it like f negative 1x. They're both the same thing. You can just leave it as y equals. But yeah. Let's see. Question number 3 says, wait a minute, I'll just erase that. G of x is 9x plus 4 over x minus 7. Let's see. Salina, what did you get for this one?
I got g negative 1 to the power thingy. Yeah. 7x plus 4 divided by x minus 9.
7x plus 4 over x minus 9?
Yeah.
Okay, nice. Let's do the last one as well. It says h of x is negative 2x minus 1 over x plus 5. 이건 지원아, 너가 이거 해볼래? What did you get for this one? Or actually,
Yeah.
도경아, 너가 해볼래? 이번 문제. 도경이 마이크 안 되나? 그럼 이것도 그냥 한번 빨리 해볼게, 이번에는. 내가. 이건 first step. We change the x and the y's, right? So we can rewrite that as negative 2y minus 1, y plus 5. Multiply the y plus 5. And we want to isolate the y. So we can just multiply the x out like that. And rewrite and move y's all on one side. So we have all the y's on one side, and now we factor the y out. Which gives us -1 minus 5x over x plus 2. If you got -5x minus 1, it's the same thing. The order doesn't really matter here. But yeah, let's move on to the next section. Let's see. Okay. Square roots. Square roots. I'm going to pick out some random questions. 5w minus square root of 27w plus 7 equals 3w minus 1. 예지가 해보자. 2번 문제.
저 이거 어떻게 하는지 잘 몰라가지고.
아, 그래? Okay. Let's try this problem then. This one might seem tricky, but all we have to do is rewrite it. So when we solve this, remember our first step is we want the radical isolated or on one side, so that when we raise it to the power of 2, the radical disappears, right? But right now, this 5w and kind of this negative is interfering. So we want to rewrite it. So if I move the 5w to the other side, I can do that, right? So I'll move the 5w to the other side, which leaves 5w is going to be -2w, right? Because we're subtracting -5w. And I'll just get rid of the negative as well. If I get rid of the negative, I'm basically dividing by a negative. So this thing is going to change to 27w plus 7, change the signs, so +2w and +1. Okay, from here, all I have to do is raise it to the power of 2 on both sides. And so the radical cancels out on the left side, leaving 27w plus 7 equals, this is going to be the same as 2w plus 1 times 2w plus 1, right? So if we FOIL it out, forward, outside, inside, okay. Front is going to be 4w squared, outside is going to be +2w, inside is going to be +2w, and last is going to be +1. And all we do is now simplify. Let's simplify. You have a 2w and a 2w here. That becomes a 4w. We can move the 27w to the other side, and also the 7 to the other side. So 0 equals 4w squared. If we remove the 27w, it's -27w. So it's going to be -23w, 4 minus 27. And we have a +1 here. If we move the +7, it's going to be -7. 1 minus 7 is -6. And now we're just left with a trinomial. We can factor this. So our first term, I guess we don't know what it is, right? It could be 4w times w or 2w times 2w. I have a feeling it's going to be 4w and w. Okay, so knowing that our n term is -6, it could be 3 times -2, -6 times 1. It's -6 times 1, -6 here, and +1 here, because if we multiply -6 times 4w, we get 24, right? -24, and +1 with w is +1. So we get a middle term of -23, which is what we want. So -6 and 1 is correct in this case. And if we factored, yeah, so we factored into these two binomials. Now to solve for W, we just set them equal to 0. Move 1 to the other side and divide by 4. We're gonna get -1/4 here and just +6 here. So those are our two solutions. Any questions so far? If not, we'll just go over one more question from this section.
Yeah, could you go over one more question, please?
Okay, yeah, I'll go over one more question. What question do you want? What question was hard?
Sort of all of them.
All of them? Okay. Let's try. Let's try this one. -4 equals 2 minus square root of y squared minus 4y plus 15. Okay, this is a 7th question. So how do we approach this problem? Well, once again, our first step is to isolate the radical. So we want this on itself by its own, so that when we raise it to the power of 2, the radical disappears, right? So how do we do that? Well, what's interfering with it? The 2 and the negative once again. Well, not really the negative, but just for simple, just so it's simple, I'll also say the negative. So to get rid of the 2, let's just move it to the other side, right? -4 minus 2 is gonna be how we do that. So if we rewrite it, that's our equation. And to get rid of the minus, I mean, this is going to be -6, -4 minus 2. To get rid of the minus, well, we just change the signs on both sides. So that becomes a plus and 6 becomes a plus as well. So we can rewrite it as +6 equals +y squared minus 4y plus 15. Okay, now our radical is isolated. It's by itself on one side of the equals sign. So how we do this is now we can raise to the power of 2 on both sides. And if we raise this to the power of 2, the radical disappears along with the squared, leaving just y squared minus 4y plus 15. On the other side, 6 squared is going to be 36. And we move the 36 on one side so that it equals 0. 0 equals y squared minus 4y. 15 minus 36 is going to be negative 15, 21, I think. Yeah, negative 21. And now that we have a trinomial where 0 equals something, we can factor it. If we factor this to two binomials, our first term is going to be y, since it's just y squared. Our last term is negative 21. We can do -7 and 3. And if we add those, here we get a -4, right? Which is what we want. So we can do a -7 and a +3 and set them, and they were equal to 0. So y minus 7 equals 0, y plus 3 equals 0, y equals 7, and y equals -3. Two solutions. Nice. We can check for extraneous solutions by plugging it in, but since this is not the section, we're just doing square roots, I'll just leave it as that. Still confusing, or can we move on to extraneous solutions? No comment? Okay, we'll just move on then. Hopefully that made sense to everyone. And now we're gonna do extraneous solutions. I'll do the last one. Square root of x plus 7 equals x plus 5. So in this case, our radical is already isolated on one side. So we don't need to rewrite the equation so that it is isolated. So our very first step, we can just raise it to the power of 2, leaving just x plus 7 on this side. And x plus 5 squared is the same thing as x plus 5 times x plus 5, right? So we can FOIL that on to outside, inside last, which is x squared from positive 5x outside, positive 5x inside, and last is going to be positive 25. And now we simplify and make it equal 0. Move everything to one side so that we have a trinomial. So we can move the x across. This is going to be 10x, by the way, 10x. So we can just rewrite that. We move the x across. So 10x minus x is going to be 9x. 25 minus 7 is going to be 18. And we're left with another trinomial. Our first term is x squared, so it's going to be x and x. 18 is going to be, what, 6 and 3, right? 6 times 3 is 18, and 6 plus 3 is going to be 9. So x plus 6 and x plus 3, leaving our solutions to be x equals 6 and negative 3. But not quite, right? Since in our very first step, we raised a radical to the power of 2 to get rid of it, we have to check for extraneous solutions. How we do that is we just plug it back in the equation. So our original equation was, what was it? X square root of x plus 7 equals x plus 5. So let's try plugging x equals negative 6 first. If you plug that in, negative 6 plus 5. Negative 6 plus 7 is going to be square root of 1 equals negative 1. Square root of 1 is 1. 1 equals negative 1. Well, that's not true, right? So negative 6 is not the answer. Let's try plugging negative 3. Negative 3 plus 7 equals negative 3 plus 5. Negative 3 plus 7 is 4. Negative 3 plus 5 is 2. Square root of 4 is just 2. 2 equals 2. So negative 3 is our only solution for this question. Okay, I'm going to go over one more question. And solving equations graphically, I don't have a graphing calculator at the moment, actually. I actually don't own one. So I'm just going to trust that you guys did that one well, that section well. And let's try square root of 3x plus 7 minus x equals, wait, minus x. But this question is wrong. It should be equals x plus 3. Yeah, it's not minus x plus 3. It should be equals x plus 3. Okay, let's try this. Once again, our radical is already isolated, so we can start by raising it to the power of 2. Leaving 3x plus 7 equals x squared plus, I'm just going to do this in my head, x squared plus 6x plus 9. If you expand that and FOIL it, and FOIL it, it will become this trinomial. Okay, and now we set it equal to 0, right? And to do that, we move this across. Minus 3x is gonna leave us with 3x. 9 minus 7 is gonna leave us with 2. And can factor. 2 is only one option. 2 and 1 do add up to 3. So we can confirm that. And our solutions are gonna be -2 and -1. Let's check for extraneous solutions now. So our initial equation was 3x plus 7 equals x plus 3. -2, let's try that one first. 3 times -2 plus 7 equals -2 plus 3 if you plug it in. And 3 times -2 is -6, plus 7 is going to be 1, right? So 1 equals -2 plus 3 is 1. Square root of 1 is 1, so 1 does equal 1. So -2 is correct. Let's try -1 then. Square root 3 times -1 plus 7 equals -1 plus 3. 3 times -1 is -3. -3 plus 7 is just going to be 4. -1 plus 3 is 2. Square root of 4 is 2, and 2 does equal 2. So in this case, we do not have an extraneous solution. Both solutions are correct. So we have 2 answers. Any questions? Or anything you want me to cover in the homework? Nothing? Okay, that's it with homework then. Let's move on to our lesson. So we have 3 lessons left. So we're gonna spend at least 2 of those lessons going over trigonometry because it's very important. Trigonometry, do you guys know what that is? Or you guys heard of it, right? What trigonometry is? Like sine, cosine, tangent.
Yeah, I've heard of it.
You've heard of it? Does anyone know what it is or like actually know how to like studied it before?
I've studied it before.
Oh, you've studied it before? Okay. I guess for those who haven't studied it before, we will go over it. So what is trigonometry first? Trigonometry is basically studying the ratios between a right triangle. So a right triangle is a triangle with a right side, with a right angle. So if it has a 90-degree angle in a triangle, that's basically what a right triangle. We can call that a right triangle. So we're studying ratios of sides. There's 3 sides to a triangle, ABC, and we're gonna see what the ratios are between each side, maybe A to B, B to C, or A to C, etc. And we label those with sine, cosine, and tangent. So a mnemonic that you guys have to memorize, you might have already heard of it, is SOHCAHTOA. SOHCAHTOA. So SOH, CAH, and TOA. Well, what does this mean, right? Well, it might be a little confusing at first. But sine means sine is opposite over hypotenuse. Sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, what does this mean, right? Well, we're studying ratios. So I draw a right triangle, a bigger right triangle. And let's say there's an angle theta over here. So theta is the same thing as x angle x. It's just a Greek symbol we use when we label angles that we don't know. So if we're given theta as our angle, and let's say this side is 3, and let's say this side, this is a hypotenuse, right? Hypotenuse is the longest side, or the side that's opposite of the right triangle. That's what a hypotenuse is. You guys should know what that is. And let's say that's 4. And what does sine tell us? Well, if we're trying to find sine of this angle theta, sine of theta, well, sine is opposite over hypotenuse, right? Opposite of this theta, of this angle, what is it? It's just going to be 3, right? 3. And what's the hypotenuse? Well, the hypotenuse is 5. So angle theta, sine theta, is going to equal 3 over 5. Let's try cos theta. Cos theta. Well, cos theta, adjacent over hypotenuse. Okay, what's adjacent of this angle? Adjacent means next to. If you guys don't know what that means, it means nearby. So this is opposite of it, but what's adjacent to it? Well, 4 is next to angle theta, right? So 4, and hypotenuse is going to be 5. Tan of theta, opposite over adjacent. Okay, opposite once again is just 3, and adjacent is going to be 4. So these, we can study these to find the ratio of the right triangle. So knowing these, any questions so far actually? Of SOHCAHTOA. Hopefully you guys know this. Do you guys know what the Pythagorean theorem is? Have you guys heard of that? A squared plus b squared equals c squared.
I think I've heard of it.
Oh, have you guys not learned it?
Mhm.
Okay. Oh, we should cover this then too.
I know what is it.
Oh, you know what it is? Okay. So in a right triangle, we said it's 3 sides, right? And hypotenuse is the longest side. So we can use the Pythagorean theorem. It's this equation here to find the sides of the angles sides of the lengths we don't know. So let's say we know that the hypotenuse is 5 and we know that this is 4. Well, how do we find this, right? We want to find this length. Then what we do is we use this equation. So 5 is going to be c, since c squared is always going to be the hypotenuse squared. So 5 squared equals 4 is going to be b. Oh, not an equal sign. Plus a squared, right? And this is how we solve for a. So 4 squared is going to be 16. 5 squared is going to be 25. If we move 16 to the other side, a squared is going to be 25 minus 16, or 9. To get the a squared, we put a radical over it, right? So that this cancels out. So a equals 9 squared, which is also the same as 3. So we can determine the length of the side using this formula. So getting into our important part of the lesson. We're gonna do the unit circle. So let's say we have a circle here. Let's say we have a circle and it has a radius of 1, okay? So what does that mean? Well, that means that this point is gonna be 1, 0. This point is gonna be 0, 1. This point is gonna be 0, negative 1. This point is gonna be negative 1, 0, right? Because the radius of the circle is 1, okay? So we graphed a circle. And I'm also gonna draw an angle, okay? So when we draw angles in a unit circle, this is always our starting point, this x-axis, this line right here. What does that mean? Well, we always draw angles starting from this point. And if we were gonna draw a positive angle, we go counterclockwise. We go counterclockwise. And so obviously if we're drawing a negative angle, we go clockwise, right? But we don't really want to get into that right now. So let's say I draw an angle around here. So that's angle theta per se. We started at this point and we don't know what it is yet, but we want this to be a right triangle so that we can determine the sides of it. So if we draw a line right here and say that's 90 degrees, that's 90 degrees. And we wanna, and let's say this is this point is point A and B. Okay, so what's the hypotenuse of this right triangle gonna be? Well, if the radius of the circle is 1, a hypotenuse has to be 1, right? Because it's going from the center to the outside. So if we know the hypotenuse is 1, can we find the two sides of the angles then? Well, we have a point AB, and this length, this x-axis length, is just going to be A, isn't it? Because it's traveling A distance. So this length has to be A, and vice versa. This y is going to be B because this point is AB, right? It's going B units up to this point, which is AB. Which shows that it's the y coordinate. So we have a hypotenuse of 1 and a point, what do you call it? A length of A on the bottom and a length of B on the right. So knowing that, I'm going to clear this up. Knowing that, and this is angle theta, knowing that if I said find sine of theta, well, sine of theta is opposite. We look here, it's opposite over hypotenuse. So theta is here, this angle, opposite is going to be B. B over hypotenuse is just going to be 1, right? Now, what if I said find cos of theta? Cos of theta. Well, from this angle, cos is going to be adjacent over hypotenuse. So adjacent we see is just A, and hypotenuse is 1, right? So sine of theta is basically B, cos of theta is A. So we see here that sine of something in a unit circle refers to the y coordinate of the point B, whereas cos of something refers to, which we got as A, refers to the x coordinate of the point. So that's something you have to memorize, and it's a very useful tool. Let's take a question as an example. let's take an example question. If we're given a circle and let's say it's like an angle and we know that's 30 degrees, okay? And we're asked, what is the x coordinate of point A? And this is point A. What is the x coordinate of this point? Well, x coordinate, is that sine or cosine? You said sine of theta is B, right? Cos of theta is A. If we're looking for the x coordinate, it has to be cosine, not sine. Sine is y coordinate. So it has to be cosine. And looking at the angle, this is 30 degrees. 30 degrees, we know that this is going to be 90 degrees. 30 plus 90 is 120 degrees. So the x coordinate of this point is going to be cosine of 90 plus 30 is 120 degrees. Okay? Any questions so far? It's really confusing stuff, I know. No questions?
Wait, go
Okay.
over again why it is 120 degrees. I just missed
Oh,
that.
why is it 120 degrees? Well, we said that when we draw angles, we start at this point, right? This line, this x-axis. And if we draw an angle all the way to point A, this has to be 90 degrees because this is 90 degrees and this is 30 degrees. We're given from here, from this point to this point, it's 30 degrees. So if you know that this is 90 degrees and this is 30 degrees, from here to point A must be 120 degrees. Make sense?
Yeah.
Or still confused? Okay. Okay, let's move on to what we usually use when we do trigonometry. So far up to this point, we used degrees as our norm for measuring angles, right? If we're measuring, let's say, this angle, we say that it's 30 degrees or something. That's the measurement we always use. But actually, the measurement that's more pure, I guess, more better, maybe not better, but more commonly used when we're doing trigonometry is not in degrees, but radians. Radians. Has anyone heard of this before? Radians. Nobody? Cool. So radians are not that complicated, don't worry. So basically, we use pi. That's what we use for radians. And pi degrees, we don't write degrees, right? We just say pi is the same thing as 180 degrees. There's the same measurement. So if there's an angle, let's say it's 60 degrees, okay? Then this is gonna be pi over 3 radians in radian terms. Pi over 3 radians, because it's 1/3 of 180 degrees, right? So there's gonna be a lot of cases where you have to convert degrees to radians or vice versa, from radians to degrees. So how you do that is we just use ratios. Well, we know that pi is 180 degrees. So if we're told to 14 pi over 9, let's say you're told to convert that to degrees. How many degrees is that? Well, we know that pi is 180 degrees. So pi over 180 degrees. This is called a proportion. We can multiply it. Since these two the numerator and the denominator are equal, we can basically multiply it to that since these two are equal. And we can cancel out. Pi cancels. And 90 and 180 cancel to make this 20. 14 times 20 is going to be 280. So it's the same thing as 280 degrees. Let's try another example. If we're given 133 pi over 72, and we're told radians, right? We're told to convert that to degrees. Then we want to multiply the proportion. Pi equals 180 degrees. And we put the pi on the bottom because we want it to cross out with the pi on the top. So pi cancels out. Wow, this is complicated. And we're gonna get a degrees. I don't have a calculator right now. I think you need to use a calculator for this question. But you're gonna get some number of degrees. And that's gonna be our answer. Vice versa, if we're given degrees and we're told to convert to, let's say 270 degrees, and we're told to convert to radians, then what do we do? Well, this time, 270 degrees is gonna be pi over 180, right? This time we don't do 180 over pi because we want the number to cancel out with a number. In the previous case, we had some number here, and a pi here. We did this proportion because we wanted pi to cancel with pi. But in this case, we don't have a pi, right? It's just a number, 270. So we want the number to cancel out with a number. So we can do that. It's the same thing. 270 times pi over 180 degrees is gonna be 180 and 270 cancel out to be 3 over 2. And we're just left with pi. So 270 degrees, in other words, is the same thing as 3 pi over 2 radians. Any questions so far? No questions? Okay. So back to our unit circle. Our circle. Back to this circle. We're not gonna work with degrees most of the time. We're gonna work with radians. So we said this is 90 degrees, but in radian terms, this is actually pi over 2 radians, right? 180 degrees is gonna be right here. So this is gonna be pi, and this is gonna be 3 pi over 2. Make sense?
Yes.
Okay. So let's try this then. Where is the following coordinate of, where are the coordinates of sine 4 pi over 5 going to be? Well, 4 pi over 5. Well, I guess if you're not accustomed to radians yet, you can convert that 4 pi over 5. You can convert that quickly by multiplying pi over 180, right? You can cancel out the pi, which leaves 30, 36, 100, like 144 maybe degrees. And we know that this is 180 degrees, 144 degrees. This is 90 degrees, this is 180 degrees. So it's gonna be somewhere here. You know that. You can do it like that if you're not accustomed to radians. But let's just work with 4 pi over 5, right? So 4 pi over 5 is not quite pi. So it's not quite 1 over 1 pi, but it's greater than pi over 2. So we know that, once again, just looking at that, it's somewhere in the middle between those two values. And we're working with sine, right? Sine is, if you remember, sine is the y coordinate of a coordinate. So if we have a point A and it's AB, then sine 4 pi over 5 is gonna be B. So the answer choice could be, you could write it as like the y coordinate of point A. So this is a y coordinate, and A is somewhere between these points. We're not quite sure, but it's somewhere between those two. So you can say the answer like that. Okay, we're gonna talk about another formula. It's very similar to the Pythagorean theorem, but it's the Pythagorean identity. So knowing sine and cos now, we're not gonna work with tangent at the moment. Remember, tangent is TOA, so opposite over adjacent. We're not gonna work with that right now. We're only gonna work with sine and cosine because of this theorem we're gonna do. So one rule is sine squared theta cos squared theta equals 1. This is a very, very important rule you have to memorize for trigonometry. So this 2 might seem weird, but basically it means sine theta squared. It's the same thing. We don't write it as sine theta squared like that because it's confusing if the squared is referring to the angle squared or the whole thing squared. So when it's the whole thing squared, we actually put it before the thing. So sine squared theta like that. Because yeah, those two are very different things. So how can we use this? Well, let's say we're given a question. The angle theta is located in quadrant 1. So angle theta is located in quadrant 1. And we know that cosine of theta is 3/8. Okay, we know what cosine of theta, and we're asked, what is sine of theta then? What is sine of theta? Well, we can see from our unit circle that it's not going to be much helpful, right? 3/8 could make any triangle. It could be like, I don't know, this triangle, that could be 3, that could be 8. That doesn't make sense. But because since our hypotenuse is 1, these values can't be any greater than 1. So we can't really use our unit circle to help us to solve this problem, right? So what we do is we use this complicated equation. We know that cosine theta is 3/8. So we just plug it in this equation. I'm going to rewrite it so that it's simpler to see. Sine theta squared plus cosine theta is 3/8, and it's 3/8 squared, right? Equals 1. So simplifying that, sine theta squared is gonna be 3 squared is 9/64 equals 1. So sine theta squared is 1 minus 9/64, which is the same thing as 55/64. Yeah, 55/64. To get rid of the radical of the squared, we square root both sides. So it's just sine theta is square root of 55/64. Or if you want to write it more prettier, sine theta is square root of 55/8, because 64 squared is 8, right? But we're not quite done yet, because when we square root, it can be both positive or negative, right? Have you guys heard of this? Like, if you do square root of 4, let's say, we're asking what times what equals 4, right? Well, it can be 2 times 2, or it could be negative 2 times negative 2, since the negatives can cancel out. So it can be positive, positive square root of 55 over 8 or negative square root of 55 over 8. So we don't know yet, but remember in the beginning, we were told that it's in quadrant 1. So our theta is in quadrant 1, which means, I guess I didn't explain this, which means that if we have an imaginary unit circle here, this is quadrant 1, this part of the place. This is quadrant 2, this is quadrant 3, this is quadrant 4. It goes counterclockwise, just how you draw angles. So we know that sine of theta is in quadrant 1, so it's somewhere here. We know that. And if it's somewhere there, and we know that it's sine, right? Sine is y coordinate. And if we look at all of our y coordinates here, well, wherever the point is, the y coordinate is above the x-axis. So it has to be positive, right? It can't be negative, or else it would be in quadrant 3 or quadrant 4. So we can rule out negative and say that sine theta is not negative, but positive square root of 55 over 8. Quite confusing, right? I'm gonna go over one more problem because that is quite confusing. Okay. So let's see, the angle theta is located in quadrant 4, okay? Quadrant 4, and we know that cosine theta is 3 over 5. This is all part of the question, and we're asked, what is sine of theta? What is sine of theta? So that's our question. We're given these three parts of information, and we want to solve it. Okay, so, well, what's our very first step? Well, 3 and 5 are greater, once again, than 1, so we can't use our unit circle to find what sine theta is. We do know that sine squared theta plus cosine squared theta plus 1. So we can use that. Sine squared theta isn't going to change. Cosine theta is 3 over 5, so 3 over 5 squared equals 1. Sine squared theta squared goes in both the numerator and the denominator. 3 squared is 9, 5 squared is 25, equals 1. We can isolate the sine squared theta, so move this fraction to the other side. 1 minus 9 over 25 is going to be 16 over 25. And to get rid of the squared, we put a radical, right? So sine theta is plus or minus. That's very important. Plus or minus square root of 16 over 25. Or you can write plus or minus 4 over 5, because square root of 16 is 4, square root of 25 is 5. So plus or minus. So how do we know if it's plus or minus? Well, now we use this information. It was in quadrant 4. Sine theta is in quadrant 4. So if we have this unit circle, quadrant 4 is this, right? So we know that this theta angle is somewhere here. And sine is y coordinate. So all our y coordinates here are below the x-axis. So they have to be negative. So we can rule out positive. So we can say that sine theta is negative 4 over 5. Questions? No questions? Wow. Okay. Well, if you guys have no other questions, then I guess that's it for the lesson today. We'll go over more trigonometry on the second day. And yeah, good luck on your homework. I'll post it on Classroom.
Thank you.
Thank you.
Thank you.
Thank you.
Yeah.